Ladies and gentlemen, boys and girls, welcome to another video. Please hit the like button, hit the subscribe button, and hit the notification bell so you will be updated on all my future content. So you are tuning into another episode of Arithmetic Mayhem. This video can be found in the Arithmetic Mayhem playlist. And for all my Arithmetic Mayhem videos, I solve problems across the four operations. So I'll solve some addition problems, then I'll do a round of subtraction problems, then I'll do a round of multiplication problems, then I'll do a round of division problems. So starting out with addition, I'm going to do one example that does not require a grouping and then one example that does require a grouping. So 343 plus 411, that is our first example problem. Just going to line up the one a little more before I start. So think of this as three separate one-digit problems. You just add the digits in each of the places. So we're going to start out in the ones place. We're going to add 3 plus 1. 3 plus 1 equals 4. Next, we add the digits in the tens place. So we're going to add 4 plus 1. 4 plus 1 equals 5. Next, we're in the hundreds place. We're going to add 3 plus 4. 3 plus 4 equals 7. 3 plus 1 equals 4. 4 plus 1 equals 5. 3 plus 4 equals 7. And we have our final answer, 343 plus 411 equals 754. All right, so now we are going to do an addition problem that requires regrouping. So with addition problems, we regroup whenever our sum is 10 or more. So looking in the ones place, we start adding the digits in the ones place. 5 plus 9 equals 14. 14 is more than 10. So 10 or more, we have to regroup. So the 4 in 14 goes in the ones place. The 1 in the number 14 gets carried over to the tens place. 7 plus 3 equals 10. We have to add the one that we carried over. That makes it 11. Again, we have to regroup because our sum is more than 10. 10 or more regrouping is needed. So the 1 in 11 goes in the tens place. The other one, the number 11, gets carried over to the hundreds place. 1 plus 1 plus 2 equals 4. And we have our final answer. 175 plus 239 equals 414. All right. Now we're going to move on to some subtraction problems. Shout out to everybody tuning in. I am glad you're here. Please hit the like button. It really helps the algorithm. All right, so we'll start out with a subtraction problem that does not need regrouping, and then we'll do one that does. Before you do any subtracting, you should always check to see if regrouping is needed. And with subtraction, we regroup whenever there is a bottom digit that is bigger than the top digit. As you can see for this problem, there is no area where the bottom is bigger than the top, right? 2 is bigger than 1, 5 is bigger than 4, 6 is bigger than 2. The top digits are bigger in all three places. So we don't need to regroup in the ones, tens, or hundreds place. So we can just go right into the subtraction. 2 minus 1 equals 1. 5 minus 4 also equals 1. 6 minus 2 equals 4. And we have our final answer. 652 minus 241 equals 411. All right, now we are going to move on to a problem that has some regrouping. For this next problem, it will require regrouping. So we regroup whenever there's a bottom digit bigger than the top digit. I always regroup from left to right, and then I subtract from right to left. Regroup left to right, subtract right to left. So in the tens place, you cannot have 4 and take away 9. We'd be in the negatives. So we have to take a 10 from the hundreds place and add that to the tens place. So the 6 in the hundreds place is going to become a 5. Then the 4 in the tens place is going to become a 14. Now in the ones place, you can't start with 1 and take away 9. So we have to add a 10 to the ones place and take away a 10 from the tens place. So the 1 in the ones place becomes an 11. And then the 14 in the tens place, we have to take away 1, and that's going to become a 13. So now making sure all the top digits are equal to or bigger than the bottom digits. 11 is bigger than 9. 13 is bigger than 9. 5 is bigger than 2. We are ready to subtract. 11 minus 9 equals 2. 13 minus 9 equals 4. 5 minus 2 equals 3. And we have our final answer, 641 minus 299 equals 342. All right, now we are moving on to some multiplication problems. So for this live stream, we are going to rock with some 2-digit by 2-digit multiplication. I'm going to show you 2 different methods for solving multiplication problems. So we have 72 times 49. So we're going to multiply the digits in the ones place and the tens place. And if our product is meaning the answer to the multiplication problem is 10 or more, we have to regroup. So we're going to start out multiplying 2 times 9. 2 times 9 equals 18. So the 8 and 18 goes in the ones place. The 1 and 18 gets carried over to the tens place. 7 times 9 equals 63. We have to add the one that we carried over to our answer. 63 plus 1 equals 64. So far, we have multiplied 72 times 9. Next, we have to multiply the top 2 digits times the bottom digit in the tens place. Since we already multiplied both digits in the ones place, we have to put a 0 in the ones place. 2 times 4 equals 8. Now, we do not need to regroup here because our product is less than 10. If our product is 9 or less, we do not need to do any regrouping. 7 times 4 equals 28. And now, to get our final answer, we have to add these 2 numbers together. 8 plus 0 equals 8. 4 plus 8 equals 12. 2 carry the 1. 1 plus 6 plus 8. So 6 plus 8 is 14. You add the 1 to your answer, you get 15. 5 carry the 1. 1 plus 2 equals 3. And we have our final answer, 72 times 49 equals 3,528. All right, now I am going to solve another multiplication problem, but I'm going to use a different method. I'm going to be using the lattice method. Another 2-digit by 2-digit multiplication problem, but for this one, I'm using what's called the lattice method. I'm going to model how to solve that. So for the lattice method, we need a box for each of the digits. So 84 times 49. So we need a box for the 8 and 84 and the 4 and 84. Then along the side, we have a box for the 4 and 49 and the 9 and 49. Next, we have to draw a line through each box, making our triangles. So now we multiply each of the digits. Our answer goes in the square, but each digit within our answer goes in a triangle. So in the top right-hand corner here, we are going to multiply 4 times 4. 4 times 4 equals 16. So the 1 and 16 will be in the top triangle. The 6 and 16 will be in the bottom triangle. Next, we are going to multiply 4 times 9. Four times 9 equals 36. So answer goes in each square, digit goes in each triangle. So the 3 and 36 goes in the top triangle. The 6 and 36 goes in the bottom triangle. 4 times 9 equals 36. So we have 3 in the top triangle, 6 in the bottom triangle. Next, we're going to multiply 8 times 4, and the answer to 8 times 4 is going to go in this square. 8 times 4 equals 32. 3 in the top triangle, 2 in the bottom triangle. Lastly, last bit of multiplication to solve this problem. We're going to multiply 8 times 9. And the answer to 8 times 9 is going to go in the bottom square. 8 times 9 equals 72. So 7 is going to go in the top triangle. 2 is going to go in the bottom triangle. Now to get our final answer, we have to add all of the numbers inside the square going along the diagonal lines. So starting out, the only number along this diagonal line that's inside the square is 6. So we have a 6 along this diagonal line. Next, we have to add 6 plus 3 plus 2. 6 plus 3 equals 9, plus 2 equals 11. Now, we have to regroup just as we would with any addition problem. 6 plus 3 equals 9 plus 2 equals 11. So the 1 and 11 is going to go in between these two diagonal lines, and the other one is going to get carried over. Next, we add all of the numbers that are in between these two diagonal lines here. One plus 1 equals 2. Plus 2 equals 4. Plus 7 equals 11. Again, we have to regroup. So we're going to put a 1 in between these two diagonal lines, and then we have to carry the 1 over and add that. Last set of diagonal lines. 3 plus 1 equals 4. And we are reading the number from left to right. So we have a 4 in the thousands place, a 1 in the hundreds place, a 1 in the tens place, and a 6 in the ones place. So we have our final answer. 84 times 49 equals 4,116. All right, so then this method that we just used, it's called the lattice method. All right, so the final round of Arithmetic Mayhem, we got some division problems. 795 divided by 5. That'll be the first of the division problems. These are very simple if you know your multiplication facts and you're very, very good with the simple arithmetic. If you have trouble with that, you can still solve these problems, but it does take a lot longer. It makes it a lot more difficult. But step 1, we want to divide by the smallest digit possible. We're looking for the number within the number. So we can actually start with 1 digit by 1 digit division if the number inside the square is equal to or bigger than the number outside the square. And for this problem, the number inside is bigger. 7 is bigger than 5. So we can start out with 7 divided by 5. We want to figure out how many groups of 5 go into 7. So counting by 5s, 5, that's one group. If I count by 5s again, I'll be at 10. That's too far. But I was able to get one full group of 5 within 7. So 7 divided by 5 equals 1. Now the closest I could get to 7 without going over is 5. So 5 is what we need to subtract to find our remainder. So 7 minus 5 equals 2. We bring down the 9. That 2 becomes 29. So now I have to figure out how many groups of 5 go in 29. So I'm going to count by 5s. 5, that's one group of 5. 10, two groups of 5. 15, three groups of 5. 20, I'm at 4 groups of 5. 25, I'm at 5 groups of 5. Now, if I keep going and I count by 5 again, I'll be at 30, and that's too far. 30 is too far because we've passed the number 29. But I was able to get 5 full groups of 5 within 29, right? I had to count by 5, 1, 2, 3, 4, 5 times. So 29 divided by 5 equals 5 with the remainder. 25 was as close as I could get to 29 without going over. So 25 is what I need to subtract to find my remainder. So 29 minus 25 equals 4. We bring down the 5. $45 divided by 5. So now for this one, I have to figure out how many groups of 5 go into 45. So counting by 5s again. 5, that's one group of 5. 10, two groups. 15, three groups of 5. 20, we are at 4 groups of 5. 25, we're at 5 groups of 5. 30, we're at 6 groups. 35, 7 groups of 5. 40, 8 groups of 5. 45, 9 groups of 5. So I had to count by 5, 1, 2, 3, 4, 5, 6, 7, 8, 9 times to get to 45. So 45 divided by 5 equals 9. And I actually landed right on 45. So 45 is what I'm going to subtract. 45 minus 45 equals 0. There are no remainders. 795 divided by 5 equals 159. All right, I'm going to do one more division problem. For this one, you'll see how much quicker it is if you're fluent and you're able to just do the math in your head. I could have done that in my head, but I wanted to do it out just to show all of you like what I was thinking, what was going through my mind. So 435 divided by 5. So again, we want to divide by the smallest number possible. Only rule is the digit inside the square has got to be bigger, equal to, or bigger than the digit outside the square. And for this one, we cannot start out with one digit by one digit division because the outside number is bigger. 5 is bigger than 4. But we can start with 2 digit by 1 digit. So for the first thing we're going to do is we're going to do 43 divided by 5. 43 divided by 5 equals 8. 8 times 5 equals 40. Now we subtract to get our remainder. 43 minus 40 equals 3. We bring down the 5. 35 divided by 5 equals 7. 7 times 5 is 35. 35 minus 35 is 0, so there is no remainder. And we have our final answer. 435 divided by 5 equals 87. All right. That is my live stream for today. Thank you so much for tuning in. Leave a comment. Let me know what you thought of the video, and if there is an area of math or reading that you're having difficulty with, put that in the comments and I will do a future video on that skill. Until next time, Christ is King, God is good, and that is my live stream. Have a great day, and God bless.